Hello.
Hello.
Hey, Jay. How are you feeling today?
Not there yet.
Oh, there. Sorry. Hi,
Uh,
Tiffany.
How are things with you?
Pretty good. Just sore fingers after typing up all this stuff.
Hi, Tiffany.
Hello. Just kind of lurking because I just started doing a new job with observability and wanted to look into this more.
Cool. Welcome. Yeah.
Thank you.
I'll give folks another couple minutes, see if anyone hops in. Okay, since it's 5 after, don't know if anybody else will hop on, but we can go ahead and get started. So after all the almost 2 years of this project now, we finally kind of have a initial release of the um, semantic standards. It's just a draft covering um, querying and time alignment, essentially, around some semantics, just the fundamentals. We don't have anything about the actual functions that we need to operate on top of observability data. Any of that, we're going to work on that a little bit later. But it's really important to build a solid base first, I think. So, I added this context document. Didn't initially intend to write it, but in order to justify the choices in a standard, you really need some way to describe why you made those choices and give some discussion around it. And I didn't want to put all of the exposition in the standards document. Try to keep it as small as possible. So we slapped all of this into a totally separate document that's now incredibly huge with tons of diagrams, tons of background. I was trying to welcome, Guanya. Trying to capture all of the edge cases and issues that we run into when we're analyzing observability data. And there are plenty more to add as we go along, too. I haven't captured everything. So we'll keep building on this document as we go through. But the initial thing to focus on really is, what's the point of this entire project? And that's to craft a semantic standard to agree on all of the behaviors when working on observability data across various systems so that we can interoperate. Um, focusing on the end users or the user experience, because you can craft anything and have a machine read it for an individual project and make sense of it as an individual developer. But if you really want a standard that makes sense and everybody can agree on and understand how it works, you really need to focus on the user experience, I think. So that means making some choices that may not be popular from a very extremely technical or correct standpoint, but make more sense from an end user standpoint. So we'll see that as we go along here in the next probably few months as we talk about all of this. So the initial thing that we did, I tried to do was add some user behaviors and personas around observability data so we can figure out who we're talking about. And of course, I'm not going to read everything. Everybody's welcome to hop in and talk. But the biggest kind of delineations and behaviors are that, one, you have a consumer who's just looking at the output of an observability query, and they just need to be able to understand what the data means, what it represents. For something like logs, that's pretty straightforward if you're just filtering on some log lines. But when it comes to something like a distributed trace or profile or metrics, it's a little messier and more complicated to understand. Then you also have the explorer, and those are people who are actually looking through the data in a system, trying to analyze it in some way that hasn't been pre-canned for them. So, folks who need to create a report for another person, or they're trying to use that data in some kind of auto remediation mode, or driving network infrastructure, whatever they're going to be doing with it. But they need to be able to understand the raw data and understand the operations on that data in order to be able to craft and analyze the data properly. Then you also have the creators, who are kind of the ones who are expected to be somewhat experts on the data, who are going to be creating alerts. They're explorers first, of course, but then they're the ones recommending and answering questions about how to use the data or what it means, etc. All of that. Any thoughts or questions on behaviors? Probably not much. And then we're talking about the personas in the next section here, where we kind of break down user groups into their primary behaviors and primary clusterings. And we're focused, of course, on the software industry or big tech right now. But observability does, of course, apply to other realms, particularly in industry, transportation, all kinds of things like that. So it's not just, and they typically don't have terms like a developer or SRE. They may have, the engineers or designers, operators, etc. So all those folks can fall on the same thing, and we're not trying to slight anybody by not using the proper terms. But the primary, or one of the main consumers of observability data in the observability realm has always been, or the tech industry realm has been, the SRE, or the system admin, site reliability engineer, whatever you want to call them. They're the ones who are responsible for operating systems. They're the ones who get paged if something goes kaput. They're the ones who are going to interact the most with observability systems, and need to do it day in, day out, and they need to be able to find the data they want as quickly and efficiently as possible. So that's a major concern, not necessarily so much in the semantics realm as it is in the syntax realm, which we're punting for later uses here. And then we have developers now. Of course, almost everybody in the tech industry is a DevOps engineer now, where you write some code and you're expected to maintain it and operate it and run it. So they are now coming in droves, and there are a lot more of them than there are SREs or system admins nowadays. And they are also consumers and explorers, sometimes creators now as well when they have to create alerts or graphs. But they're one of the biggest users and consumers of observability data. And then we have what we're calling PLOs, or platform library owners. They're the ones who develop something like Kubernetes or gRPC, or maintain database systems, etc. And they're the ones who will set up alerts and dashboards and observability signals for developers or other folks to consume, the other people who are using their platforms. So it's important that they're around and supported, well supported, because their systems have a wide impact. If you write a library like Spring or something that's used across every project within a company, and you have metrics coming out of that and logs, etc., that you have a big impact versus somebody who's creating, let's say, just a shopping cart application. The next one that we haven't thought of traditionally in observability so much, but is much more important nowadays, is data science engineers. They used to be just focused on business metrics, right? For the most part, looking at, what somebody was checking out, what the clicks, what somebody's experience was when they were going through a website, trying to monetize the users and pull all of that information together and drive business decisions. They're still driving business decisions, but now they're looking at observability data more and more and more, particularly within the realms of capacity planning, finance and efficiency, looking at things, how business decisions impact cost or efficiency. So that we've seen that a ton at Netflix. So a lot of big companies have seen that as well. So we do need to support data science engineers more and more as we see observability expand. Then, of course, the last one, we don't have any company with executives or management, so they do interact with observability data. Of course, they're primarily just consumers when they're looking at dashboards. A lot of data is going to be rolled up into a dashboard or something by the time they see it. Managers more close to the developers are going to look at data sometimes directly and play around with it. So they need to also have an easy way to understand what they're looking at whenever we give them some data. So we have some examples like UI engineer, development or performance engineer, product managers, SREs, of course, security engineers, etc. And then we added some support requirements trying to, in this document, I wanted to be able to tie back the reason we make these choices to the operators of observability systems. So I've been running them for a long time now. And I know, always seeing all the questions that come in saying, oh, what does this metric mean? Or how do I query for this? Or, what's the right way to do this? Part of the goal of this standard is to make it so that it reduces that burden on us as observability operators. It'd be great if we can standardize and everybody consuming it can understand, learn everything once around how to interact with observability information and then not bother us anymore and just ask for features. That'd be great. It'll never happen, but, it's a nice kind of goal, I think. So we talked about the amount of support each group or persona kind of needs. So developers, they're diagnosing new issues and they're generally unfamiliar with observability tools. So again, focusing on understanding, that's really important. The platform library owners, they're generally a little more experienced with observability tooling because they're building observability into their libraries and platforms. SREs, of course, are the experts. They use it day in and day out. DSCs are very good at analytics, so they're usually coming to us saying, hey, what's this data? What does the data mean? What kind of operations can I perform on it? And how do I access it? And one of the big issues there is around DSCs consuming monotonic counters. That's a real pain to describe and support and tell them how it works. And then management, again, they're looking at rolled up data. They almost never actually need support. And then to quantify it, at Netflix, I grabbed some data from our Slack channel. So I looked at it, and actually the developers and PLOs required the most support. So I was just looking at how many people, or the title and position of the people who open a new question. or a topic within Slack. And surprisingly, or not surprisingly, SREs opened very few because they knew most of the data, but developers were huge, 80%. DSE, the science engineers, like I was mentioning, about 10% were opening questions there. And then management, that was mostly local teams, local managers looking at some information. And then we also looked at the number of calls grouped again to observability tools. And hopefully this information will be useful to somebody out there too. But surprisingly, it was actually the PLOs and developers and DSREs that were making the most calls. You'd think that SREs would be making the most calls into observability, but again, because there are fewer of them compared to the ratio of developers and PLOs, they don't have as much usage compared to everybody else. DSEs too were making quite a bit actually. So again, this kind of plays into or describes and defines, quantifies the hypothesis that more and more non-SRE folks are using observability tooling. All right. So any questions on that, personas? Any thoughts from anybody? There wasn't a lot on the internet about this, though. I did see Guanya and Stana had a nice little page about observability personas too, so that was kind of useful. All right, and then another aspect of the semantics, and the document is describing where we've come and what kind of data we have. So I do want to go over this. I want to talk a little bit about the history of it. And the important things here to know, or see how observability has evolved over time, seeing some of the things that people have tried, etc., on and on. So the first thing that we ever had were logs, where people would just print out some information from their applications to standard out or standard error. These were almost always unstructured, like, I started my application foo, I processed 42 entries in 5.134 seconds. No more data, so I'm shutting down. And these were all new line delimited, and you could easily grok through it as an end user or developer and understand what's going on. This really stinks though for machines to read and work with though. Eventually added timestamps, and then we got to a point where, hey, we wanted more structure to this so that our machines could work with it. We could write filters to figure out what the important things are. Maybe we could write some automation to take action. So early on, we Unix and I think it was the IETF created a syslog standard where we started adding some structure around timestamps, the process ID, a priority to determine whether the message was, critical or something requiring action, or if it's just informational, etc. So now we have this format that you can print out. You can pick the fields you want. You can route it to different locations and merge it and analyze it in any way, shape, or form that you want to. So that was really useful. Then we started having logging frameworks for applications where you could, in your code, kind of provide a little more structure and say log.info, and then you could provide a template where variables are filled in, and the logging framework would automatically add some timestamps, add some context, like the instance it was running on, the file location. It could do more advanced things like routing it to syslog, route it to files, eventually route it out to other databases. So that was very useful too. And then you had some tools like Sentry, open source Sentry, that would take these parameterized queries and break them out into dimensions, kind of like attributes in OTel. Then there's another issue where some tools like Elasticsearch and Splunk came along where they could parse in something like JSON and break it up into different fields if you didn't have a nice complex pipeline to work with. So developers started putting in JSON encoded log lines. So they just, JSON stringify an object, dump it in the log system, and then pull it back out later. This was kind of a way to get around, to provide wide events of what some folks talk about nowadays. And we'll get back to that in a second because wide events are actually really old. So just to recap, you always have a timestamp. Generally, we started having sets of labels and tags for logs, etc. The drawbacks, of course, for logs are that the unstructured ones are really difficult to parse for machines, but easier for a user. Security is also a huge concern because somebody could dump personally identifying information into a log line, and all of a sudden it's on disk and it's spread around all over the company. And if anybody has the rights to look at that log, they can, access critical sensitive information. And then at scale, with a really busy system, developers are pushed to reduce the amount of logging that they have in order to save CPU cycles, sometimes disk if it's writing disk, and then some actually turn to sampling of the log information. So any questions on those on logs? Pretty straightforward. Everyone knows them. Metrics, everybody's pretty familiar with, I assume. They're just numeric summaries or snapshots of a state at a particular time. Pretty straightforward. A string, a human readable string name, a set of labels, tags, or dimensions, usually key value pairs. They have a timestamp. If it's a gauge, it's just a single timestamp or a snapshot. If it's a counter or a delta counter or something like that, monotonic counter, it may be a range, so it may have two timestamps. And that's covered in a different section. Again, drawbacks for metrics are they're considered low fidelity because you're summarizing a lot of information. You can't add a ton of tags. If you do, eventually you wind up with events because you have a unique set of attributes per measurement. And generally metrics are the cheapest way to observe a system too. So metrics don't have to be sampled because incrementing a counter or setting a number is essentially a single CPU operation. Events then kind of came out of the fact that people needed to track and join their metrics and logs with operational behaviors like deploying a new software version. So events came around with a start and an end time. You could generally overlay them on a chart. And if you saw a spike in something, you'd add the events and you'd say, oh, my deployment was going out this time. That's why I have some errors or a change in CPU behavior, and understand what's going on there. The issues with events is that you need a database capable of modifications because an event has a start and an end time. You generally, in order for it to be useful, want to push the event as soon as it starts and have that be able to be queried. But then after the event is over, you want to update that end time so that it can roll on into the past off the charts. Not too many observability systems support updates very well. A lot of the focus has always been on write once, read many times, just because of the vast amount of information that we get. So those are the kind of drawbacks there. Usually people return to logging stores or traditional RDBMSs to store that information. Then with distributed traces, early on we had logs where you could put a transaction ID, let's say starting at an API. You could track a transaction ID and pass that along to every step in your microservices infrastructure, or early on when it wasn't really microservices, just different services. And then you would log that request ID each time. Then you'd search through all the logs for that ID and try to kind of join them together in a transaction workflow. Eventually that was formalized, especially by the W3C, into distributed tracing, where they recommended a way to pass that context along and define spans that then build into a trace. So these just make it more formal and a lot easier for systems to reason about and standardize on. So, hey, here's an observability standard that we've agreed on, which is kind of nice. Another one. Syslog was one too, of course. Another one is SNMP that we'll talk about eventually. They always have a starting timestamp, and then the span is a measurement amount of time that the measured span took. It has, again, a set of labels, tags, or dimensions, and then a type like client, server, publisher, etc. The drawbacks, again, are that it's really super useful for tracing them out, but again, just like logs, you tend to sample these because at large scale, they capture, excuse me, and emit quite a bit of data. And then there's also, again, security concerns with PII data sneaking in. There's less security concern about metrics with PII because they'd have to stick it in tags. Does happen, of course, but less of a concern. And then profiling has always been an aspect of observability. Well, not observability so much as development, where developers need to figure out what is causing a program to be slow or use too much memory, etc. So you use a profile to dig into the internals and look at system calls, memory allocations, mutex contention, thread usage, all that kind of information. Nowadays, it's come into the observability realm where we're doing constant sampling of processes. And thanks, Wanya. And now it's added as another signal because you can also derive really useful information from profiles like finding those functions that may be impacting performance across an entire fleet. The drawbacks, again, are that there's a ton of data in a profile, so they're sampled again, like logs and traces. And then it's also like distributed traces are a graph, profiles are also a graph. So you need some useful or some important semantic predicates on top of this data to find useful patterns. And then you also need operations like being able to walk the graph of calls. So that makes it a little more complicated. And then wide events, like I mentioned before, is making a comeback. The earliest example of this really is just the Apache HTTPD access log format. Maybe not the earliest, but one of them, where every request coming in, you recorded things in a standard format like the client IP, the server IP, the amount of time it took to satisfy the request, the response code, the number of bytes sent over the wire back to the user, etc. So this was all defined in columns, data types were defined, and you could store that and process it in things like the old AW stats that would chunk that or analyze that data and show you, where people were visiting from. It would join that data with geographic databases to add the country code, etc. That's just an early form of observability, really, that we're turning back to with wide events. But again, wide events are very expensive because you're capturing a lot of data. People tend to selectively measure what they want, and then sampling comes back into play again. So some folks nowadays are claiming, oh, all you need is wide events, right? You don't need metrics or logs or anything like that. I don't think that's the case. I think we're going to need all of these telemetry types going forward. It's always going to be a case of end users determining and deciding what makes the most sense for their use case. And then another important data type, I don't know where this came from, I might have to remove that, is business data. So again, observability is no longer in a silo. We're seeing more ties between business data and observability data, where DSEs are looking at it, where SREs are looking at the business side, DSC is looking at the observability side. So even though the terminology changes, essentially what everyone's looking for is a giant data lake where they can query anything in any way, join it however they like, and derive useful meaning from it. So those are all important types. All right. Any thoughts, questions? And then this section was on timing. So it was going over the different signals and what they represent. So again, this is another issue around why I don't think any individual telemetry type is going to disappear, particularly around metrics. Let's say you're tracking an event that takes, what did I say here, 40-ish seconds or so. So you have a start of the event. You might have a span, distributed span that started, and within the application, the context is captured in memory and sitting there. Some systems may emit the span and be able to update it like a event. Most systems don't. So at this point, as an observability system, you have no idea a new request has come into the system unless you log it and say new request from user XYZ started. Then after a little bit, you might see a metric counter incremented, and it might make its way into your observability system. And you can see, oh, I have one request in flight. Then with continuous profiling, you may have a profile that starts automatically, and it's going to capture, I think, what did I say, 15 seconds of data here. Again, you have another metric scrape or publish that's showing, again, the request is in flight. And then eventually the request completes, and only at that point do we emit the log in the span. And then that data is available to consume and query. So this is, again, showing why metrics are still useful, particularly with long-lived requests. For a very short-lived request, which the vast majority of requests are, it's not as useful, but in the long-lived case it is. And then you see at the end here, another metric scrape occurs. The in-flight drops back to 0, but our request count incremented to say that we had a request that came there. And this is all just talking about that. So just want to document that and talk about it. Because one super important thing here when it comes to looking at semantics is how do we break up and analyze this request? When we're querying and we say, we want to fetch all time series data from, let's say, T15 seconds to T60 seconds. Do we include this request in there? Usually we do because it finished within that time range. But should we look wider to see when it starts? Or do we slice off just the portion of the event that occurred within our query window? These are all the semantic things that you have to think about when you're developing an observability system and when you're consuming information from it. So that's a lot. This right here is pretty much why this document is gargantuan, trying to talk about and lay out why this happens. And why it's important too is that a lot of times when analyzing observability data, we're looking at logs and metrics, logs and, logs and traces and converting those into metrics. Okay. Excuse me again. Any thoughts on that? All right. And then we talk a little bit about why we started this project and why we can't just use natural language or AI or white events. Why do we need a standard at all? And we kind of talk about the reasons here. I get into the observability 2.0 and the white events information here. If anyone wants to dig in, talk about how HTTPD was one of the initial ones and why they are super useful, but there are also some issues around the white events, like always capturing more context. So some folks argue, yeah, just throw every context you can in there, and like the user's IP, the username, the request itself. But you can't always capture all that information. It's not present or not feasible to push down to the applications. So at the end of the day, you still have a lot of context outside of a system that you may need to join on that data to enrich it in some ways. And this is a perennial topic. I forgot to add a section to, but I need to, around whether or not you enrich data before you emit it and store it, or if you enrich it afterwards. And there are cases for both. And we'll have to talk about that a little later. Another super important thing around wide events is security. Again, the wider and the more context you push people to add, the more likely it is that they're going to put PII information in there. And so that's going to push observability systems to either support RBAC authentication and authorization, and fall under all kinds of regulatory compliance like GDPR and SOX compliance, which typically has not been something we've delved into with observability information. Or you have to split that kind of information off into a more secure store and be able to join it later, which leads us to the next section down below. And then another reason why we need some kind of standard like this is that we want to be able to correlate the various telemetry types. Again, I mentioned that a lot of the observability work is just transforming profiles, logs, and traces into metrics to analyze it. You want to do things like look at the metrics when a specific trace was executing that may be associated with that trace. Or you look at the traces associated with the metrics, or you look at the logs during a metric incident that have the same attributes and tags. So that's why it's very useful. As you can see here in the example, we have the service name, and the service instance ID is the same across all the profile types. You have a trace ID linking across here. You may have one of these trace IDs as an exemplar in the metric, even the OTel standard has it in profiles, etc. So that's why it's important. I talked about the conversion here. Profiles. Again, wide events can be turned into traces. Traces can be turned into metrics. Events turned into metrics. Profiles metrics, etc., etc. Another question that comes up though is, aren't the models too different? They are different, but not so much that we can't kind of flatten them out and work with them together. Particularly in OTel, we have the standard of attributes now, where you have key value pairs that are applied to every type of metric or telemetry type. So that's great. We can join them together. It's really nice. Nothing kills productivity like context switching. So if you have to write a PromQL query looking in the dashboard, then you have to jump to Elasticsearch and remember ElasticQL or ESQL or some other system. Pain in the butt to do that, I think. Another question comes up, particularly today. Can't we do this all with AI? Eventually, we may be able to, but having a standard is going to assist with that, particularly around the semantics of operations. Natural language to the data is something some of the folks are working on too, but that's not cost effective yet to vectorize all of the telemetry that comes into our systems. It's not, observability isn't a money maker, it's a money saver when you can use it to avoid an incident or solve an incident early. So they're not going to give us enough money yet to, vectorize everything, I don't think. I think samples of it are going to be vectorized, and that makes sense. Subsets of that data. Otherwise, what they're doing right now in the industry is focusing on traditional monitoring that triggers an alert, and that alert then triggers a model to go query similar information as close to raw as possible, and then vectorize just that subset and derive some insights from it. So that's pretty fun to watch. Eventually, we'll have reasoning models that ideally you could just point them at the database source code, and point them at all of the sources that are instrumenting metrics, and then it would be able to learn and reason about how to query that effectively. That's kind of like the dream goal, and eventually we may get there, but we're not there yet. And there's also the case that proprietary vendors may not want to offer up their data sets or code to MLs that are used. And then again, for cost, it's still really expensive to query all of this data to have an ML or large a model of some kind generating a query for constant queries like alerts, something like that. So you may use NL to craft a query and then paste it into some system that fires that query off more and more and more. And then another reason is semantic convergence, where after we started looking at all these DSLs that are out there for observability, they're all kind of doing the same thing, just with different syntaxes. And under the hood, they're all doing similar stuff like grouping, aggregations, joins across data sets. And surprisingly, from the interviews, nobody really said that their DSLs were incredibly tightly tied to storage. They wanted them to be able to be flexible so they could swap out the storage behind the scenes. So that leads to the recommendation. Why reinvent the wheel when we already have SQL semantics that everybody seems to be going back to after trying NoSQL, graph databases, everything like that. Everybody's coming back to SQL, the industry standardizing on it, the data industry, that is. So the recommendation here is to follow SQL semantics. I think next session we can dig into that some more. So this doc, or all these docs, are kind of starting to float around in the industry. We're having folks look at them, comment on them. If anybody out there checks out this video afterwards, please leave your comments. And Tiffany, VJ, any questions from y'all?
No, just trying to absorb all this. There's so much stuff.
Yeah, the doc is huge, and yeah, we'll have more sessions like this and keep discussing it. But yeah, any questions, feel free to ping us. I'm happy to help.
Yeah, I think I'm gonna have to go through and read the doc before having some questions.
Cool. All right. Thanks.
Thank you as well. Learning new stuff.
All right.
This is really elaborate and fantastic. Thank you so much, Chris. I think maybe let's set up some time offline and chat a little more about this.
Cool. Will do. Sounds good. All right. Well, thanks, y'all.
All right.
Shut down and
Thank you
care.
so much.
All right.
Have a good rest of your day.
Thanks. Thanks, Tiffany. Thanks, VJ. Bye.
Bye.